Hello, welcome to Physics with Johnny. Today we are going to discuss Newton's three laws of motion. I'm Johnny Huyu. Give me the camera. The cameraman is this guy, Christian Huyu, and we're going to be having the help of my buddy, Edward Cullen. He's a vampire. Well, I suppose you can't say it like that. He's been through a lot with me. He's a trooper though, and he's a good friend. He wants to be in this video. So, anyways, here, take that. First, we are going to discuss Newton's first law of motion. Newton's first law states, every body continues in a state of rest or of uniform motion in a straight line, except insofar as it is compelled to change that state by forces imposed upon it. Or, if you weren't born in the 1600s, an object at rest will stay at rest, and an object in motion will stay in motion, unless acted on by an outside force. This is also called the law of inertia. First we will discuss an object in motion will stay in motion unless acted upon by an outside force. Pretend this is a car. It's not a car, but pretend it is. If the car is moving and then stops by an outside force, Edward goes flying. That's why we wear seatbelts. But he seems Next, an object in or at rest will stay at rest unless acted on by an outside force or a force that's under it. Thank you, Edward. Are you having issues? Well, why don't you stand where you're not in the way of the wind? We need this outside force, Chris. It's your one and only job. Don't let us down. Physics is counting on you. Outside force. And things move. Where'd he go? Newton's second law states the acceleration of an object as produced by net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Basically, this means anything that is accelerating, there is a net force pushing that. Net force equals mass times acceleration. So basically, let's say you've got a 50-pound cannonball, right? And it's going to accelerate at 10 meters per second squared, which is really slow, but we're just saying this for whatever. Anyways, the net force of that would be 500 newtons, I think, because force equals mass times acceleration, or force equals 50 pounds times 10 meters per second, which equals 500. Yeah. Alright, so mass times acceleration equals force. This thing will represent force. So then however much a tape weighed times how fast it accelerated equals how much force it was. So if that tape weighed 50 pounds and it had an acceleration of 10 meters per second, it would have had a force of 500 newtons. Newton's third law states, for every action there is an equal and opposite reaction. So now we know all of Newton's three laws of motion.